All right, so we want to write the expressions first and then simplify. So for this first one, we're writing just what we see. In the positive region, we've got an x and 3 positive tiles. Minus, in the negative region, we have an x and a negative unit tile. Equals, in the positive region, I've got an x tile and 2 negative unit tiles. Minus, I've got an x tile and 2 negative x tiles. So on this, there's nothing I can do to simplify inside the parentheses or outside the parentheses. So I'm just going to go ahead and do the opposite. So this will be x plus 3 minus x plus 1 equals, see, this is going to be x minus 2. Now this one I can simplify inside, so I'm going to do that. Minus a negative x. So this side is going to be 4 because the x plus negative x add out to 0. This x minus a negative is the same thing as plus a positive, so that's 2x minus 2. I'm going to add 2 unit tiles to both sides to get rid of those 2 negatives. And then divide by 2. We get x is 3. Any questions about that one? All right, let's do the same thing here. I've got 2y minus, in parentheses, y minus 2 equals negative 2 minus a negative y. There's no simplifying that we can do either inside or outside the parentheses on either side. So I'm going to go ahead and just do the opposite. So that'll be minus y plus 2 equals negative 2 plus y. This gives you 1y plus 2 is equal to negative 2 plus y. If I subtract a y tile from both sides, or remove a y tile from both sides, I get 2 equals negative 2. Is that true? Is 2 equal to negative 2? No. That's a false statement. Anytime you end up with a false statement when you're trying to solve one of these, the answer is that there is no solution. It doesn't matter what value y has, those two things are never going to be equal to one another. So, speaking of that, last night while he was doing his homework, Richie came across 3 homework questions that he thinks have no solution. So it asks you to build these and determine if it has a solution for x. If it has a solution, find it. If it does not have a solution, explain why not. All right, so let's go through this. I've got an x squared and 2 unit tiles in the positive region, minus 2 negative x's in the negative region, equals, I've got an x and 2 negative unit tiles in the positive region, minus a negative x squared minus 1 in the negative region. We need to simplify these, but there's nothing I can do inside the parentheses because there are no like terms in the parentheses. And there's nothing I can do outside of the parentheses, so I'm just going to go ahead and do the opposite. So this is x squared plus 2. The opposite of negative 2x is positive 2x. Equals, here I've got x minus 2 minus a negative, that'll become plus x squared, and the opposite of negative 1 is positive 1. Can't do much on the right side. I am going to put them in descending order of power, the squared term and then the x term and then the constant, equals, this will be x squared plus x minus 1. Well, I can get rid of an x squared term on both sides. 2x plus 2 equals x minus 1. I can subtract an x tile from both sides. So I'll have x plus 2 equals negative 1. To get rid of the positive 2, what do I need to add on? A negative 2. So he's wrong. This does have a solution. The solution is x equals negative 3. All right, let's move on to the next page. So the original expression, and again, I do expect you to be able to write the original expression, is x plus 1 minus 1 minus a negative 2 equals x plus 3 minus a negative x plus 1. On the left side, I can see that the negative 1 and the positive 1 are going to make a 0 pair. So this is just going to simplify to x minus a negative 2 is plus 2 is equal to x plus 3 plus x minus 1. Remember, we're doing the opposite to the things that are in the negative region. So that's x plus 2 is equal to 2x plus 2. Subtract an x tile from both sides, and we get 2 is equal to x plus 2. Subtract 2 from both sides to get the x by itself, and you get something that is a perfectly good answer. X equals 0. Students sometimes lose their minds when you get x is equal to 0. But basically what they're saying is that the x needs to be 0 so that you can wipe it away from both sides. And once you do, then these two sides are going to be equal. So x equals 0 and no solution, not the same thing. All right, let's try this one. A lot more tiles here. So I've got negative x plus 1 minus 4 minus 4 minus 1 equals negative x minus 2 minus 4. The left side I can do a fair bit of simplifying right off the bat. I've got negative x, 1 minus 4 is what? Negative 3 minus 4 minus 1 is 3 equals, here I'm going to have negative x, and negative 2 minus 4 is negative 6. So combining the like terms, we've got negative x minus 6 equals negative x minus 6. Well, you can keep going if you really want to, but does it matter what x is then? This is true. The solution for this is x is any number. It doesn't matter what x is. It's always going to be true. All right, let's see what we can do with these. So this one is pretty straightforward, I think. What would be the next step to getting x by itself? Pardon? Subtract 2 from both sides. So if the opposite of x is equal to 2, then what is x going to be equal to? Yeah, the opposite of 2, negative 2. All right, let's go on to page 3. Simplify by combining like terms or any other simplifying that you can do before you start moving things around. So on the left side, 4x plus x is 5x minus 2 equals 2x plus 3x is 5x plus 8. Subtracting the 5x from both sides gives you that negative 2 is equal to 8. True or false? False. So what do we say then? There's no solution. You can never make those two equal to each other. No matter what you do. All right, let's try C. So combining the like terms, 4y plus y is 5y, minus 9 is 16. I'm going to add 9 unit tiles to both sides. So I have 5y is 15. Divide both sides by 5, so I just have one y tile is going to have to be 3. God bless you. All right, let's look at this one. There's no simplifying I can do inside the parentheses or outside, so I'm just going to go ahead and do the opposite. So the opposite of 2 minus 3y is negative 2 plus 3y equals 6 plus 2y. The opposite of 5 plus y is negative 5 minus y. Now I'll group the like terms. I like to put the term with the variable in it first. It doesn't matter though. That's 3y plus 7 is equal to y plus 1. Subtract a y tile from both sides. We have 2y plus 7 is equal to 1. To remove the 7 positive tiles, I need to add on 7 negative tiles. So that'd be 2y is negative 6. Divide by 2, and we get y would have to have a value of negative 3. Any questions? Okay,